Sure.
Thank you very much.
Yeah, wait.
I figured I'd leave this to the last day so I can make a quick getaway afterwards. This will be it's not even a roasting or anything. It's just a few of the little doodads that I've noticed since I've been here and even before. And I'll make a couple semi-serious points toward the end that we can throw up for discussion. I'd be interested in getting your feedback on. I should say I'm grateful to David. I'm grateful to all of you for the experiences I've had in my 2 months here. I've learned a lot in my embedded in the troops situation I've been in, and anyway, it's been an honor to be with all of you, and you've been very patient with my stupid questions and my silly observations. So I'm really, hopefully I can come back and do this again sometime. I'm told by telling you that there's actually a tradition in physics of top 10 lists, which I actually spent the last 10 minutes on the web looking for one. I don't, you ever,
I'll find it.
You have to find it. So this will probably be quite tame compared to some of the ones that you were telling me about. In fact, I think of it as, if you know you're a theorist, when, and where I'm going to fill in the ellipses on that. So one thing that struck me for a while is the extent to which theorists love walking. In fact, this is a quote from Nietzsche, and this is a tradition really that goes back before physics was even defined as a subject. Aristotle, known as the peripatetic philosopher, would walk and talk at the same time, and that seems to have been carried on into future generations as well. And everyone here has been carrying on that proud tradition. Every time I visit someone in their institution, we immediately go for a walk across the campus. At the Institute, I've been around that pond a million times. I've bbeen along the shore of the Mediterranean. It's something that seems to be part of the feeling. But KITP takes it one step further, so to speak. You do your best work when on 2 feet or 2 wheels.
2 seconds.
Sorry?
No, just answer. Okay.
So one other thing that struck me, and a number of people told me this, I won't name any names, but I'll use John Wheeler as an example, where to learn general relativity, he says that he taught a class at Princeton in the subject. So I've actually been told that by a number of people in this very room and elsewhere, that to learn something, they actually decided, hey, a good way would be I should teach a class in that subject, and then, of course, the students ended up teaching them as well. This, unfortunately, is not a picture from the 1952 class that Wheeler taught. And I've actually heard this in other fields, not just high-energy physics and high-energy theory. Alain Aspect taught himself quantum mechanics while a volunteer in Africa. He was there for, I think, 3 years and took some textbooks and taught himself quantum mechanics. So this is a tradition in many different fields in the sciences, but I'm struck by the way it works here and in this room. I presume also we wouldn't want this to be true of medical school, for example. You wouldn't want your doctors to be taught by people who are just understanding the body at the same time. So it's something specific to more theoretical subjects.
Presidents.
Sorry?
American presidents.
They seem to be taught on the job, too, unfortunately, for all of us. But one kind of corollary of this is the extent to which everything I've seen here in the workshops and the sessions I've gone to almost is a continuation of that tradition. You're always teaching each other things, and I've been very struck by that. And I've been to workshops and conferences in a lot of different fields in the sciences, and the pedagogical tradition seems to be strongest, at least in this workshop. Maybe I've missed something in these other fields, but it does seem to be strongest here. And one kind of corollary to the corollary is that I think you take it as a principle that if you know something truly, you should be able to explain it to somebody else. But you can kind of reverse the logic. And if someone can't explain something to you in a way that satisfies you, you begin to doubt that argument a little bit. And that's an impetus for honing it. So I've seen a kind of interesting feedback loop in that where in that break room over here and upstairs, the same discussions have been taking place and slightly honed each time as you try to work through an idea and explain it in better and better ways. And I've been very struck by that. I've also been kind of swept up in that myself personally. This is a direct quote from somebody here whom I won't mention, has said that the discussions they've had with me has helped them, that person, to understand the subject better than they had. So somehow we science journalists are kind of in that little loop of pedagogy, which I think is kind of cool. even when people write Scientific American articles, I'm often told, wow, I can understand my own subject better than I had before I wrote the article, which is good because I prefer that than the alternative.
So if you want to understand something, teach it, and if you still don't understand it, then write it up for Scientific American?
Yes, exactly. But just don't tell my boss that. So, David asked me just a few minutes ago whether I wanted to be interrupted, and I said, well, would it kind of go against one of the slides in my talk if I said I didn't want to be? So, one of the things I've been very struck by is the extent to which talks are continually interrupted, and that is definitely more than any other field of science that I've ever had any pleasure of being in. Even workshops of this sort, which are kind of more informal than a conference, people in other fields just don't interrupt as much. And I think that's a cool kind of aspect of the.
But that also differs from country to country.
Does it?
Yes.
Yeah, Russians interrupt a lot more than
Oh, really?
Americans. Yeah, Russians are just unbelievable.
And New Zealanders and Brits interrupt less.
Oh, really?
Yeah, British people are too polite.
When I go home to talk in New Zealand,
Yeah.
or go attend a talk and ask some interested questions during the body of the talk, it's considered a great, faux pas.
Right.
You're
Oh, boy.
supposed to save your questions for the final 5 minutes,
Exactly.
and they're supposed to boost the speaker.
Certainly
and
in
make them look
Japan, for example.
Oh, interesting. Okay, so I'll have to put a footnote in this.
Russians and Israelis.
There's that, the interaction between teacher and student is something that is strongly suppressed in kindergarten and the next 2 years everywhere, including this country.
Mm-hmm.
So it's something that we try to foster at the ATB. And so before a program begins, I lecture the coordinator about proper behavior in the institute.
Oh, I didn't realize there's an undercurrent
So
here.
there is and it is certainly true that Europeans typically require more education than Americans. But it's an ongoing effort. So the workshop that you attended was very well. And it's a community that is disrespectful from the beginning.
Excellent.
So it's great, but many programs it doesn't work that way. You really have to try to encourage them to. And we're creatures of habit. In most universities, if you go to a seminar in most universities, you will not get away with it very much because people have an hour and then have a class and
Right.
we're finished their 70 transparencies and slides and questions at the end.
But David, despite that, in our kind of field of theoretical physics, at most universities in the U.S., there are still lots of interruptions during the talk. It's just the speaker at the end that has to pay for the last.
The ITP is added in.
Perhaps that's true. Perhaps that's where it is.
I think it is to some extent. It's partly the culture of the community.
Yeah, it's the culture of the community.
This community is nice and irreverent.
Anyway, I just, as an outsider, I very much enjoyed this tradition. And when there were talks when there weren't interruptions, I was beginning to wonder whether that indicated something. So I did.
Actually, it's usually the feeling if no one interrupts, then we all don't care. In which case, it's not a very good talk.
Or we're all just lost.
Okay.
Or that, we're all just lost.
You're checking your email.
Sometimes I also think that there's this is working on a couple different levels. In a sense, you're not just probing the science in that case, but the person themselves and how they think on their feet. So it's kind of an interesting dynamic that's taking place.
But George, it's definitely not a natural thing, especially in Asia. I once went to a summer school in Taiwan, and the organizers actually offered the students money per, so many dollars per question.
Oh my God. I think we bankrupt the NSF if we did that. Interesting.
That's pretty.
Did it work?
Quite extreme.
Did it work?
Did it work?
There's a phase transition as a result of the control parameter.
Sometimes when I'm giving a talk, if there aren't questions, I'll refuse to continue unless
I do
someone
the
asks
same
a
thing.
question.
Is that right? Wow.
I do that in class.
In class I'll do that all the time. I think this is actually a corollary of the whole understanding things better from teaching, because I'm remembering back when I was just a student, before you teach something, one overestimates the extent to which it's rude to interrupt the presentation, and even if you think it's okay to ask a good question, but then when you actually teach, you just see how much you're reliant on feedback from your students to know whether you're hitting home or not. And one starts wanting to beg them.
But do you ever feel that the questions can steer the conversation in a direction you as a speaker didn't want? Like maybe it's more technical?
That's part of the skill in being the teacher or the speaker, is learning how to guide that conversation back on track. How not to allow it to get too far from what you were hoping for. And that's a real fine line. It's like walking a tightrope sometimes.
That's interesting. One corollary before going to the next slide, which is related to this, is that the first time I saw this whole dynamic in operation, I saw someone give a talk, and I probably wasn't here, but elsewhere I've seen this. And then people would interrupt with these incredibly sophisticated questions, like, wow, after 30 seconds of discussion, you formulated, just based on 30 seconds of discussion, that incredibly sophisticated question. But then I would see maybe that speaker could talk again, that audience member there, and they'd ask the same question. So this kind of leads me to my next point, which is that there's an ongoing conversation in the field, and the talks, actually I've really only come to realize that firmly here, that each talk should be seen as one moment in an extended conversation. Just to comment on this quote from Weinberg, which is actually an interview he did for Scientific American. It was in the context of being at a blackboard or working on paper all the time, that being a solitary aspect of what you do. And he would then say, well, one of the reasons we go into these extended conversations is to build the sociality back into our work. But I think Heisenberg really put it very well.
Weinberg is notorious for not co-authoring papers. He's almost all his papers are single author. Like almost all of them, most people here have collaborators. Weinberg is kind of an exception, I would say.
Interesting. I hadn't really processed that fact.
Well, different scientists pick different styles. Some people prefer writing single author papers, some people prefer collaboration. It's probably healthy to have different types of styles.
It seems so, yeah.
But that quote from Weinberg is really bad. I think he would deny it.
Yeah, Weinberg has a habit of making quotes that get pulled out of context, as I've done here.
You should either erase it or check with him whether you want to give it in any, because it really isn't true. And that, by the way, is the myth that I often talk about. That a lot of lay people think of theorists, especially, or anybody in academia as a cold and open.
And Sir Lewis, when he was giving a talk at Stephen Hawking's 70th Public Symposium, he made an explicit point. He said, if you want to be social, go into science.
It's exactly the opposite.
Okay, maybe before I give this to publish, I'll clarify that, but I called out this quote specifically because he then went on to say something just like that.
Out of context.
Well, it was out of context with a purpose. Okay, mea culpa. But this is really what I wanted to focus on, and this is actually from one of the editors of Physics Today, and he was engaged in a debate on this question of physicists had this reputation, and he was trying to argue against that. And I certainly have imbibed that since I've been here, and I didn't mean to suggest by taking this out of context that I didn't. I will say it has taken me a little time to get used to the conversational style here and how people were thinking and talking and thinking and talking, so it's been kind of an interesting lesson. And I think I mentioned this in my last talk. There are certain euphemisms that come out that if you're kind of unaware of that style, you might misinterpret. People say they, what were some of the ones I have here? Oh, often, good question means, I've been thinking about that too, haven't I? Or I don't understand it. Sometimes, doesn't always, but sometimes means, God, I really think you're crazy. So one thing I've also observed, and people tell me some of the backstories of their own lives, is the extent to which they're... Which one? Oh, this...
Sorry.
I won't say who gave me that quote, but it is a person here, and I think it's quite interesting. Again, the point is that I think most people I've talked to had an interest as children in mathematics and in science generally, but their actual professional careers have been bouncing around between different fields, especially, I think, in this community, between condensed matter, understanding more condensed matter issues, and basic theory. And anyway, I've heard all these wonderful stories about people ping-ponging back and forth like a pachinko machine in different areas, and actually that's where this really came out of. This person who gave me that quote had done a lot of thinking at the end of between condensed matter and...
See, the point of this is that you can't do this as an experimental physicist, right? You tie your equipment, your lab, and so on.
Depends
very hard to.
What your skill of experimental
There are
physics
few
is.
people that have switched around, very few.
In quantum optics, where you just have an optical bench and you can move things around easily, I think people do move
Well,
around.
Perlmutter, for example, was a particle physicist who went in cosmology.
It can be very time scales are longer.
Yeah, the time scales. You can do different things. Theorists could do different things in the morning and in the afternoon. Yeah.
That's right. That's right.
Theorists are dabblers. Everyone likes dabbling.
So I took kind of an informal poll in my discussions, informal, extremely unscientific. How many projects are you working on at a given time? And the average is really around 3, but the deviation, the range goes from 1 to about 10 was the range that I got. And in addition to the ones you're actually working on, most people say they're thinking at a deep level in their brains, maybe about half a dozen others, and then they cycle through those ideas as they get stuck on them or as they accomplish something. One of the great things, and one of the reasons I came to the BITS Brains program in particular, I wanted to be here for this program, was that there were people from different approaches to these problems coming together, and it seemed to be kind of this interdisciplinary effort, which is great. It's something that has been commented on by, again, I'll quote from Heisenberg. But one question I wanted to throw out in a semi-serious way is, has it really helped? Because when you get people coming from different approaches, it's sometimes a little uncomfortable. People who think problems are settled in one area might conflict with people who think the problems are still open in another. Maybe that discomfort's a good thing. It actually is a creative friction. But I just put it out as a question whether these interdisciplinary and cross-approach programs actually are productive. Let it cogitate, and we can come back to it in the discussion.
The answer is there are two different definitions, two different axes in which you might measure productivity.
Mm-hmm.
Right? They are very useful for exactly that, making people in one field realize that maybe a problem hasn't been solved and needs to be gone over that grade level. This is kind of like explaining something to a non-expert that, again, is the iteration of the cycle.
Right.
Very useful for that. Is it as useful for pushing forward technical results in a subfield? Does it push it along as fast? Typically, no. So,
okay.
depends on your goal.
Yeah, that's good. One would hope, though, that technical methods that one area develops might be applicable in some way to another.
That can sometimes work, depending on what subfields get together.
Right.
Well, a classic example is the Anderson-Higgs mechanism, superconductivity.
Ah, yeah.
So I don't know what Don means by technical.
I think it's a fairly the interdisciplinarity in a broader sense is sometimes can be when Dean talks to me about interdisciplinarity, my brain just shuts off and thinks about physics because it's a much overused term which has new value. And so within the context of this kind of meeting, I think it's a very valuable thing. But broader context is usually one of those words like sustainable that has no meaning.
There seems to be some quality becoming an academic administrator where they teach you the secret handshake and you begin to think a lot about interdisciplinary institutes and so forth. So to me, again, as an outsider, there seems to be a lot of benefit in that, but I can wonder kind of how it works at a more mechanistic level. How does it actually work?
It's hard to train someone as an interdisciplinary person. You need someone with a disciplinary foundation, like somebody who knows the techniques and the methods of physics, and they can, from that disciplinary basis, then go and do interdisciplinary work later. But it's, you don't see programs producing so many students that are designated as hybrids.
In fact, there's a danger of becoming, is it the master of none? Kavli is the master of none. And you need a thorough grounding in one thing to be really good at, and then go out there. Training interdisciplinary students is a disaster.
There are probably a few people who do it quite successfully.
See, well, Heisenberg is of course correct, and the reason that people focus and talk about and try to promote interdisciplinarity is that Heisenberg is correct.
Yep.
So certainly insights from one field can shed light on.
The problem is you can't just bring disciplines together. It's not even clear what disciplines are.
Yeah.
This program, to argue that this program is interdisciplinary is stretching of what a discipline is.
Interapproachionary.
Very hard distinction, to say the least. It does bring people all of whom are theoretical physicists and are educated in a single discipline with a very strong culture. But we're approaching problems that used to be regarded as distinct, now recognized as the same problem with slightly different approaches. So this is, although it's stretching to call this program interdisciplinary. It's not stretching when you bring condensed matter physicists, say, and atomic physics together to describe, which is an example of a truly interdisciplinary effort that has happened here and really had a big effect in the field. Because they actually didn't know each other's language, even though they were within the same discipline of physics. They really needed to spend a good part of the effort to learn the jargon and the problems and the state of the art. This hasn't really been true. These communities.
That's right. There's been a shared language and set of values and understanding of problems, definitely.
But the problem that a lot of places have with pushing, the reason that your pick is so right, is that people think that you can achieve what Heisenberg says has often happened artificially by simply bringing people together. People don't come together fruitfully unless they're both both groups, both people are interested in the same problem. So it really what works, and it's one of the goals of an institute like this, is to identify those problems where it is hard for people to get together for institutional or other reasons, or simply language. They don't understand what the other people are talking about. But they're both interested in the same problem. And that happens often, certainly in biology, where if you think bringing general relativists and string theorists together is difficult, or there's any difficulty in communication, you try to bring a biologist and a theoretical physicist together.
I imagine that'll happen with the cancer program beginning.
It happens all the time.
No, we did that in 2000. It was the year of biology.
It happens every year.
It happens.
20% of our activities are such programs. And that's true interdisciplinary, and it requires enormous effort to first just create dictionary, ways of different communities talking to each other in a way that they understand. But it's all predicated on that, what Heisenberg said here, that there are all these points where different disciplines, different lines of thought meet at interesting problems posed by nature. And so it can work, but you have to have the problem. This program has a problem, which we've recognized for a long time now, on slightly, marginally different communities, which for a chemist look identical. That's only to a theoretical physicist that could distinguish between...
So when you do bring the biologists in the same room as the physicists, do you have to have an explicit, we're going to have a dictionary talk?
Here. They sit here for 3 hours every day, and you remarked that in the physics program there's a lot of interruption. Those 3 hours a day, there's hardly an organized talk. I mean, it's just continual discussion. Very interesting.
And then the language issues get hashed out on...
Yes. So what happens is programs like this, part of the goal is not just during the lecture, series of lectures. It's also community building, collaboration building. So communities get formed that persist beyond the program. In the case of biology, it's at a time where a new community of theoretical biology is growing in the world.
Of course, you never know when it's going to happen. When a famous example around here was a program on polymers and a program on magnetars, on stars with high magnetic fields. And as time went on, people realized that they both were worried about long, stringy things winding around and started to collaborate with one another.
That's very
and brought
interesting.
insights from one field to the other.
Wow. And that wasn't even an explicit effort to bring those two groups together.
They were two different programs.
Meeting at the coffee time. That's interesting. One of, I actually don't have a quote for it, but Schroeder wrote an essay about how, at least from his point of view, theoretical physics was very playful. It's a kind of an extended form of play and developing the curiosity. But let me just put one other slide up in a second. It's playful, but I think sometimes I wonder about it's a difficult job that you have. This is a community. I think someone said to me the other day that you're only as good as your last paper, and I think that's true in every profession, but it seems to be really true here, where you're surrounded by people who are incredibly high-powered and ready to pick apart anything that you do. And I imagine that must be tough at times. And I'm curious how you go through. These are people kind of in maybe, actually, this person was not here, but this person was, and saying it's sometimes really difficult for us to kind of work this through. And I think it was especially true for a lot of people when they were students. I mean, we all have, I remember when I was in graduate school, the first year was just, you're always questioning yourself and wondering, am I good enough? And I think that's even more true in theory. So like, someone remarked this to me, and it's difficult, I think, for students, and when you're a postdoc as well, you're afraid that you're going to look stupid in front of smart people, and that'll affect your career possibilities. So I just throw that out because I'm curious about what you think about that, and we can talk.
I would wager that we're probably not that much more insecure than anyone else in academia. I don't know whether this was completely wrong, but I know a lot of other disciplines. I've met a few people in other disciplines. I'm a member of a college at my university where we're fellows in all these different areas and so forth. So I think there is insecurity, a lot of insecurity in academics.
That's undoubted.
You can think of it as a way that we take risk. I mean, we are good insurance risks to insurance companies. So professors have generally really good benefits, but we take a lot of emotional risks in our lives in the academic context. At least that's true for me. I don't know if other people would say the same thing. But.
No, it's definitely true in other academic disciplines. So I think maybe the ratio of jobs to students is higher in theory.
It has changed also over the years.
Okay.
I mean, I think there are epochs where jobs were easier to get, and epochs where jobs were harder to get. And so the drive, how much insecurity drives your doing in physics is usually a strong function of the job market.
Very true.
I think if anything, people in the sciences are kinder than people in the humanities.
That's the stereotype that I think is true.
Right. My fiance was doing an English master's degree at Penn State, and there's the insecurity there as well. But I think there's when it's really technical and everyone partly has to help each other just understand what's being said, you have to cultivate at least some level of friendliness. And when you're talking about something more like social science or something,
there is the great advantage of the sciences. Great advantage and disadvantage is that the ultimate judge is nature.
Yeah,
not other people.
It does help.
Yeah.
It's true in mathematics too.
There's also the possibility, I think, to observe generosity even within the context of insecurity. So I don't think it has to be one or the other. I see a lot of people having insecure experiences, and at the same time, they're being really generous in another scholastic context in research or in teaching or whatever. So I think if you can somehow balance those things, it helps to.
I imagine it's also dependent on. Sorry. I imagine it's also dependent on institution and environment there. And this was a comment just lower one at SLAC back in the 70s.
Makes a difference to how this sort of thing is handled.
The senior guys at the top of any institute are the people who generally shade the level of encouragement and the level of dog-eat-dog or collaboration. And that's very much a function of the people who are senior and tenured in place. It's part of the job of being, when you're the senior tenured person, try and set a good tone that's encouraging.
And different places will have very different styles. You know, some places will have very productive results from really dog-eat-dog environment and virtually no generosity, and yet other places will manage to have a more, in my opinion, healthy mixture of the two and still be immensely productive. So it seems there's no right answer as to how much of that needs to go on to produce productivity according to whatever metric people might agree on.
I went to talk by Joe Nolero last night, and he was talking a bit about creativity, and I don't agree with everything Joe Nolero says, but he made some interesting points and anecdotes. And one was about West Point. So apparently the Army at one point, so to speak, maybe 20 or 30 years ago, was worried about the attrition rate for their cadets at West Point. So they started to pay more attention. How do we keep these people that we've brought in and encourage them and keep them as cadets and eventually Army officers? So they started tracking some of the cadets more carefully, and maybe they would give them only 10 miles to march that day rather than 12, or 40 pounds to carry in their pack rather than 50. But they would tweak the challenges they would give them, and they found that eventually in the end they all got to the same place. They were all able to achieve the same by changing some of the early expectations. And I wonder whether that might be true of students as well. I'm sure everyone here encourages your students, and that's part of it, but you know, some students do need more help, especially in the first year. I remember my first year in graduate school. It was tough, and I went caving 2 weekends. It took 2 weekends out. This is my big get out of my office, get out of my classwork mode. I never caught up the rest of the year on my problem sets because just 2 weekends out from that threw me so far behind and everything else, and I was struggling the rest of the time to catch up. So I don't know whether that could have been easier on me. I mean, I did get through it. I'm happy with the outcome, but nonetheless, you do wonder whether that could be lessened a little bit. Anyway,
George, I think I think several points that Amanda made is very useful to you, because some of those titles you really, I think, varies from field to field and from institution to institution. And this, the discussion that Amanda mentioned, that different institutions is shaped by the senior person. It relates to this slide that you showed earlier about Wheeler, about learning from the student, because the students ask questions. When I took the quantum field theory course from Schwinger at Harvard, it was made clear to the students that you're not allowed to ask questions. Just not allowed to ask questions, period. If you raise your hand, Schwinger will just ignore you. And you might run the risk of being ejected from the class.
Wow. So it does depend on the person.
Everybody has a different style. Wheeler and Schwinger are different.
Very much so. By the way, just for the record, I was one of those students who always pestered the classes I was in with a million questions, and I'm sure annoyed some or enlightened others. So I don't know how that works out, but I think that's a positive good. I think it's good to have that kind of dialogue.
But, I mean, what is it? This last quote seems to me is very.
That's not true either.
I mean,
Europe is few fewer questions.
Depending on the personal experience.
True.
I've given
I mean, I throw it out as an observation that someone recorded.
It's a point that I've heard, it's an observation that I've heard other people make, that people, for example, in front of Edward Whitman are afraid to ask a question in case the great man thinks that they're less than perfect, you know. But I think most of us tend to get over that fairly quickly because we realize that it's tactical to do so. If you don't learn to get over that, then you don't make as good progress in your productivity, which is what you're judged on once you've graduated. So, you know.
I'll come back to a point about this later as well.
Can I say something about this business of insecurity? It's not just a matter of culture or habit or personality. There's an external force, which is that there's a very large number of people who want to become theoretical physicists who don't, and who sort of basically realize at some stage or are informed at some stage that they don't have what it takes, or maybe there are people who do have what it takes but still don't make it. And so there's this very large external force making people insecure for very good reason.
Yeah, that's a great point.
Right. Do you think it changes the approach that physics as a whole takes to problems? But
this is true in every area.
Not really. I
mean, think of movie actors.
Deal with insecurity all the time. Right?
Or music or-
There's not a single adult who doesn't deal with insecurity problems.
Absolutely.
Right? And how we deal with it has got a lot to do with what we end up getting done.
Yep. In fact, my next slide will also be something that's common to almost every academic discipline, and which I think you'll recognize as well. And just the reason I actually put it here in coming after the previous slide in my presentation is I think one of the ways you overcome this feeling of insecurity is you develop strong friendships within the community. Then you're not as worried about saying something you think might be stupid. So these are just a couple anecdotes that people gave me. I redacted a name there, but the person actually, they became quite close collaborators. This was actually more of a comment on the way it works out in different fields in academia, even different fields within physics. It strikes me that the fields I've observed here are extremely ideas-rich areas. There's almost too many ideas. So that's not the problem here. But there are fields where there are fewer ideas and people are scrapping around a little bit more. And I think that does change the social dynamic that takes place in those areas. One, and I brought this up in my first talk, is human anthropology. There's only so many bones in the ground. And that's one reason that John Johansson won't talk to Tim White. I mean, these are incredibly bitter priority disputes that take place in archaeology and in anthropology. That is just nothing I've seen like that in any other field. Those two people, by the way, won't even talk to Scientific American anymore because we deign to talk about the other person's work. So it's actually it's really unhealthy.
Exclusive.
It's a problem, I think, in that area. And
Well, it depends, those are observational fields.
yes.
With very limited data. And there are, you're going to experimental science is much more larger than that.
Also, if there are stakes, I have a couple of friends who works very deeply in AIDS research around living vaccines, and it's one of the most bitter and nasty fields known to mankind because the stakes are so high.
Yes.
Lots of ideas, lots of data.
This field is unusual because it has absolutely no commercial value.
Yeah, it's the
That helps.
It helps.
It really helps.
It's the Kissinger, the Kissinger quote. What is it?
I mean, it really benefits from that. One of the reasons people are friendly is no money. There's no money to be made. Theoretical physics really benefits. I mean, largely. And you can see what happens to fields that are within our domain, sort of as some kind of commercial aspect develops. People change.
True. Or people are drawn in that hadn't been drawn in before.
The social aspect is partly about trust building. After all, if you're friends with somebody and they do something that's not so awesome, you give them the benefit of the doubt because you expect that will be repaired at some later point because you've got a trust relationship. But if you have none such, then...
Yeah, I think there's a lot to that. But I mean, everyone wants to work with people they like. I mean, so it's also just that simple urge that we all have.
The difference is that I, over a long career, have noticed in a different period of this kind of physics. This is also a field which is largely removed from everyday experimental direction experimentalists. So there are very few. I mean, you can argue. I mean, people might argue among themselves, and about who did what first, or they've written similar papers and so on. But again, the impact is within the community. It's a very small group, and not with the real world or nature through experimentalists who are in general antagonistic to all of us and are out there, serving as testers of these ideas. And so this community overlaps considerably with particle physics, which used to have such a. And in the days where there was, immediate contact with experiments, the field was quite different, more competitive, and nasty, and proprietary. The things you described, you don't see it. So you don't see it for good reason. This is the Garden of Eden. Innocence.
Just watch for that apple.
What?
Commercial innocence.
But not just commercial. It can be academic.
But it works both ways, though. I mean, philosophers could be very angry at each other. But I also made the point to you that condensed matter physics, when you talk about theoretical physics, you really mean this kind of fundamental physics,
Yes.
black hole, string theory, and so on. It's not true in condensed matter physics, where your ideas could be nullified by experiment within months. So it's not the question of I'm smarter than you are. Just whose theory is correct. The experiments come right out. There's no room for arguing. So I think it's very different. All the things you said tend to relate to
This
this
is
one.
more,
I can see that.
more closer to mathematics in the sense of rewards.
Right.
And
Exactly.
security, intellectual security.
Yeah.
So, I mean, what people here, unfortunately, I mean, I don't regard, that's not a good thing. It's much better to have nature than rigorous mathematics. But to a large extent, what people here value is the mathematical consistency of these ideas and richness of the ideas as opposed to experimental verification.
What makes it feel nice and what makes it effective may be two different things. It sounds like what I'm hearing, but for niceness, you sort of want to go to extreme. You either want lots of experimental data or none at all. If you have none at all, like us, or I don't know, maybe the evolutionary psychologists or something, then everyone can just speculate to their heart's content, and there's room for everybody. And if you have lots of experiments, there's lots of things to do. If you're all competing for the tiny amount of things that are the only allowed sort of experimental backing, then people are going to be more vicious.
Interesting. I mean, I hadn't done that systematically, so I don't know whether that
It's just
correlation is.
I'm sort of distilling an idea I heard other people saying. It might be interesting to test it.
I think you need either experiment or internal consistency or both. And philosophers don't have anyone.
I'm just going to say, we say something in favour of jerks, but frankly, when I've had a heated interaction with colleagues from time to time, and it's been protracted, it's actually made my science a hell of a lot better. So you want some friction in the field, otherwise it gets too friendly, and it's really important to have that friction. So if it gets too friendly, then we all, our standards drop and say, oh, that's okay.
I can see that. But conversely, if it were, there must be some happy medium between the two, because if it became too nasty, then you wouldn't put out ideas.
Right, but a little bit of both is needed to help, I think.
But I think that even in fields where it's very nasty and there's a lot of competition, the statement you make that professional and personal life go together, you may very well still be true. It's just you have your own crowd, you have your own friends, you hang out with them, and you can go skiing with a few people. So it's a bit disconnected, like the statement you make.
Yeah, that's fair. I will say I do think this is a general condition in academia and probably in any kind of middle class, upper middle class profession, that we forget that is not the norm in our society. Most people have very different personal and professional lives. They go home at 5 and that's very different. So I'm always struck by that whenever I venture out into the real world and see that it's not the same as my own direct experience.
You hear people using physics language to describe personal things.
Anyone see that Woody Allen thing about using Calabi-Yow's to explain inter-office romance? It's been done. So yes, but I definitely I've heard Markovian and non-Markovian apply to human relationships when I've been here. I mean, I've heard a lot of different jargon words, and it's fun to do that. And it does. It's pretty apt.
It's the infamous two-body problem,
which is soluble usually, but except with humans. And then finally, one that is probably obvious to everyone here, but is not obvious, I think, to the public. And this is something I'm going to try to bring out more. This is, except to The Onion, bless them, I think The Onion should get some kind of science journalism award for telling it like it is. So everyone I've been to immediately will acknowledge that what you're doing is incredibly difficult. But I think the public, of course, thinks it's difficult too, but they assume that you know what you're doing. And sometimes I think I need to bring that out a little bit more. I mean, I'm generalizing, of course, as you tend to do in these kinds of
Well, it's as hard as it can get. If it was easy, it would have been done. It's just like
True.
Which is
all discovery of interesting things are controversial because otherwise it would have been discovered a long time ago.
Again, this is extremely obvious to everyone in this room, but it's not obvious to the public, and it's been a goal of mine to try to make it more so.
It's probably because we don't really engineer opportunities for student discovery experiences in school, in compulsory schooling sector. Students are often sort of told, get the idea that science is about getting the right answer, and if they don't do it right, then they're obviously not meant for
Well,
science.
it's not easy to engineer
I'm not saying
opportunities of things that have been discovered.
True. But you can do
Actually,
it.
I once thought of when I first started teaching in Princeton, I said, this is crazy. We never teach our graduate students what real science is like. You know, we teach them from textbooks. And so I thought it went quite far, but in the end, it was too much work. To try to design a course in which you lead students to a recent, let's say like 10, 20 years ago, recent scientific discovery, and to choose an area where they didn't know very much. And this was before the internet. So one could imagine, denying them access to information and lead them through, some development in theoretical physics, provide them with experimental input, experimental results, some of them wrong, some of them right. And they would come up and try to recreate for them what real science is like. Very hard to imagine doing that.
like most inquiry-based teaching, it's a lot harder than it looks.
And now, given the internet, it's impossible. But in lieu of that, how can you ever train, not to speak of high school students, graduate students? So the only way, and this connects to what you were saying at the beginning, if you really ask how we train graduate students to do science and not to learn textbooks, learn a subject, it's the apprenticeship method. And what goes on in the rest of our lives is continuation of that. That's how we were taught, by conversation, by example, by working with students. And it just continues because we don't know, there's no other way of really conveying how you go about getting insights or how you think of life, how you come up with new ideas. How are you going to teach somebody to come up with new ideas?
It's oral tradition and kind of a tacit acquisition of knowledge.
It's something.
In other words, the easiest way to do inquiry learning is to hook them up with an actual incomplete research project.
Yeah.
But sometimes they need to have such a level to do that.
Field theory is in kindergarten.
But George, again, earlier, with some of the remarks, I was just thinking, I agree with physics is hard. And I agree with that statement. But it's because most people's brains are not wired to do theoretical physics. Some of our brains are not wired to write a symphony, for example. I mean, writing a symphony that people want to listen to is also hard. Right? And you can think of many other things that are hard. But it all depends on what your brain is wired to do. Writing a great novel is hard. So.
Why is it? I don't think we have to teach people how to come up with good ideas. I think we have to stop sending them to schools that teach them for 12 years how not to come up with good ideas. I think that's the problem. But what you were talking about on the internet, I ran a math circle, and I tried to do in 90 minutes, a mini version of that with math for younger people. And what the best ones are when you're like experimenting. There's some things that are true, some things that are false, and by the end, you know what? That one's unknown in 3 dimensions. In fact, there's $1 million prize for it. But getting all that in 90 minutes, because if you don't, then they do go and look on the internet.
Not in kindergarten. They're Google Scholar skills. Not there yet.
My students aren't quite there yet.
There's Siri.
But I wanted to say something else. I'm not a theoretical physicist. In fact, I'm not even a physicist. But I was at Jonah Lear's talk last night.
Oh, good.
Yeah. And most of the things that you put here, I would say, are true for all creative endeavors, not just for physics, not just for other academic areas, but for other creative areas. And things like, you get your best ideas when you're walking, and it's the spontaneous collaboration. And he was talking last night, this was so interesting, about Steve Jobs designing Pixar and putting the bathrooms really far apart so that people would have to run into people from other departments and have conversations, and it would promote that spontaneous collaboration. And apparently, he said, everybody there has got their bathroom epiphany story. But the other one was 3M, that you talked about like the random walk. That's not a random walk. They had that forced, what did they call it, forced transferring or something, right, from one department to another, where they had to apply their same ideas and training to a different field. And it seems to, promoting creativity, those principles seem like really general for creative subjects. Not all academics is creative, but I'm talking about the creative.
Sure.
Non-academics too.
True.
I'll just go back to one of your comments about interdisciplinarity, and it reminded me of a story. I try and explain to undergraduates sometimes the difference between being a physicist and a mathematician. And I sometimes describe the mathematicians as being like nation builders and physicists are like pirates. Interdisciplinarity, what does a physicist do? There's a neat piece of math there called entanglement entropy. I'm going to run in and grab it. You grab the neat stuff, you use it for your own purposes, and you have a good time. Be like, whereas if you really want to build a field from a foundation upwards, you have to work really, really hard. That's math. That's nation. There are some physicists who are like nation builders, and there are some mathematicians who are like
I need
pirates.
to think about that analogy.
The pirates nation builders model is actually not a bad one for the. And interdisciplinarity, yeah, you go to somebody else's discipline, and study the stuff and use it where you're working on the problem that you're interested in solving. But maybe a bit much.
Interesting. Pirates. Just a few quotes that I've collected from this. The point about this first one, by the way, goes back to how we teach our students, because I think a lot of students, maybe a lot of people here, as when they were students, went into physics precisely because it was the Everest to be climbed. It was the difficulty of the field was actually part of the attraction. I don't know how many people think that, but certainly when you've been doing it for a while, it kind of changes its character a little bit. These two quotes came from it was back when we were talking about higher spin gravity. It's told a couple of people, wow, I really don't understand this at all. And then I got people saying, something, we don't either. So it was kind of a fun point.
Do you know why physics is considered so hard by the general public? I mean, given that these other things are also hard.
Well, mostly they don't have math.
Yeah. Isn't it just math?
It's partly that, but I think it's the abstraction of it.
They're good. Try explaining music to someone who's deaf.
Yeah, but most people aren't deaf. You can be if you're the mini, you listen to the symphony, you can't write it. Whereas if you're a mini, you're going to have difficulty listening to the physics.
They are math. But mathematicians also find physics difficult. So it's not just math. That is a good part of it.
I think, I'm puzzling over this myself because, frankly, for me, when I'm reading a Scientific American article in biology, or molecular biology, I find that more difficult because there's a lot of terminology that I have to keep track of. Okay, was that the receptor, the protein, the gene? And they all have similar names. So I think every field has aspects of it that are going to be difficult.
We can,
Agreed. No, I'm making a separate point, which is that what do I personally find difficult about the biology is not just that it's jargon, but there's a lot of pieces that have to be remembered, and there's just a sheer memorization challenge to it. In physics, I think the challenge may be, for most people at least, it's very abstract. A particle, is it a feelings? It's difficult for us to relate to it. So it's just a thought. And there may just be a hangover of all the years of being told that quantum physics is so incredibly weird. It's weird.
But we shouldn't complain too much if you talk to mathematicians about how they feel about how the general public looks at them. We can talk about quarks, They can't even say what a group is.
You're going to show pictures.
You know?
Yeah.
So we don't have it the worst.
Right.
I was going to
By any
say
stretch.
that I mean, math is just as hard, if not harder, than physics, but the general public thinks physics is harder because they don't even think about math. They have no idea what mathematicians do. They can't imagine it. They think they can imagine what physics do, and it seems hard. I think that's the layman view.
It's the connection to reality that they cannot make.
Sorry?
It's the connection to reality that they cannot make, the general public. They cannot imagine what a force is. We're talking about.
There's something associated with the way that we think too. One of my kids, my daughter, wanted to go into physics when she went to college. She took the first course. She said, "I don't know how you people think."
Was there something specific
She dropped out of it.
that she remarked on?
No, it was the whole course. She said just the nature of the logical process that was employed in analyzing physics problems. It was foreign to her, and she couldn't deal with it.
Well, it's very amphibious. So some people can do the math, and they can't relate it to, and they intuitively know about physical things, but they can't do the sort of hybrid, almost word problem type. This is at the same time an abstraction and it's something in the real world, and somehow have to know when to let the abstraction slide and when to let the real world slide.
An example of what you mean?
That's good.
Well, like for example, if you're doing a physics problem, you can't just turn it into an equation. You have to know what you can ignore, what you can neglect. You have to have a sense for. If you just follow the math like a mathematician would, you will end up in the wrong place.
Well, that's what you mean just fine. So, I mean, the best example of this is mathematicians trying to learn physics. So when string theory and quantum filters began to have a big impact on mathematics, and so physicists were no longer pirates because they actually needed stuff that wasn't there, so they had to create it and steal it.
Had some slaves do it for me.
Mathematicians.
Have some slaves do it for me.
But so, and there was a 2-year course at the Institute for Advanced Study that Lane and Witten ran, teaching mathematicians, very good mathematicians, by and large, physics. And those are 2 volumes, and which are really difficult to read. I couldn't even understand the lectures I gave there. So what they did was take these brilliant mathematicians and decided they were going to teach them physics so that they could think like physicists and invent all these wonderful things that physicists were inventing. And they did it from the top down, of course. They taught physics the way we understand it. But they had physicists teach physics, and then they translated to mathematics. And they had mathematicians who flipped into physics teachers. And it didn't really work. I mean, so some of these mathematicians learned a lot about physics, but they didn't learn to think like physicists.
I think one of the key differences, I put it sort of colloquially, but physicists deal with what I would call an approximately true theorem. Now, if you say that to a mathematician, they're just going to parrot pain at that point. But approximately true theorem is something where you may not have quite pinned down all the assumptions. You've missed maybe a couple of things, but there's a core truth that you know is there, but you don't have your definitions quite straight. But let's try and figure out the consequences. So, in the sense they don't pin everything down, they just keep going. Mathematicians have to have every definition, every aspect of the thing pinned down before they can move. And physicists just run.
But so it's hard to get that. You can't get it even if you're a brilliant mathematician, 2-year graduate course. The way we do it is the hard one. We take the students for many years and teach them physics from the bottom up, not from the top down. We take them through classical mechanics and laboratories and hands-on, and that somehow develops the kind of intuition that you're trying to describe that mathematicians envy, because it's not in the equation. It's in our hands, and it comes from the way we educate people to be physicists. And it's hard because it takes a long time. doesn't seem to be any shortcut that we know. That's why there aren't that many prodigies among physicists. It's a very brilliant group of people, but you don't get the kind of 16-year-olds who are solving Hilbert problems in theoretical physics. It's not. It takes time to develop this physics culture.
And that intuition, as you said.
Yeah, and
that you know it's true.
There really is not. There isn't any shortcut that I know.
A lot of people do attempt to find a shortcut and fail. They often send us books and CDs and DVDs and theories. And
you get those too.
Yeah.
Oh yeah.
I get a theory of the universe in the mail every week.
And I know this crackpot because they'll begin the letter. I really enjoyed the article you wrote. Because it's usually people write in with crackpot or they hate the article. So if they write saying I enjoyed it, you know that's in category number 1. Let's see. And finally, I mean, this is not part of the 10, but I just wanted to throw out a few questions that, I mean, we probably don't have time to talk about here, but we can talk about over cookies as well. This is actually something I brought up with a number of people, this first one. And I think, David, you actually mentioned in the very first session we were here, boy, how are you going to turn the entire blackboard maybe twice over filled with deep questions? Don, were you the one who just was systematizing them into like 8 categories?
It was my task, yeah.
And then it was, oh my God, how are we going to make sense of these different questions?
Are you going to summarize, Don? The answers?
We have a panel at the conference whose job is to do that.
So that to me is a mysterious aspect of how it works. I think, Jim, you and I were talking about this a little bit, and you would actually give me a few heuristics for exactly how the questions can be translated into actionable to-do items. And one was you generalize, see connections, or a couple others you told me. I can't remember offhand. Bartle's 4 laws of translating big questions.
Things that are irrelevant.
Yes, but that's which of many things.
there's always Gross's maxim, which is when in doubt, calculate.
Gross's maxim?
I'm sure it's not only him who came up with that one.
Well, there's a law that whatever person the law is named after wasn't the person who invented it. Anyway, so.
What is that law named after? That's George's, right?
Sorry, we call it my law, but there actually is it's on Wikipedia or one of these places. There is a law that goes by the X principle, that person's principle, where no principle is ever named after the right person, including the person who named that principle. So it's self-consistent. This is something this will have to be an ongoing discussion, and it came out a little bit in the talk that Paula gave, because Nova obviously is going to be talking more about process of science. In Science American, we try to talk more about the content. But sometimes I wonder whether we need to adjust that balance as well. And this actually is something I just added based on Lara's talk yesterday, because it strikes me a lot of the creativity that comes out in this workshop and other places, other events here at KITP, are exactly the kinds of things that Lara says need to be replicated in corporations, government, God knows government, all these other places in our society.
I like it.
Sorry?
I like it. Get it some play. Get it so that people notice that this is something that they're doing and doing really well, and that it's leadership stuff. I mean, if nobody ever knows about it, then how will people know?
Okay. That's a good place for me to end it, because that's going to be one of my jobs is to distill some of these things and do precisely what you're suggesting. Any other thoughts or comments before cookie time?
Thank you for putting up with so many interruptions.
No, I enjoyed it. I really enjoyed it. Thank you.